Hello, ladies and gentlemen. Welcome to Physics 20, Acceleration, Kinematics Lesson 3, Uniform Motion Acceleration. Now, in the first part, we talked about the graphs you'll see. In this part, we are going to look at a curved graph, and we're going to estimate the velocity. Now, notice here in this handout, this is distance versus time. So this is a velocity graph. You'll also notice it's curved. So my question is, how do you solve for the velocity, say, at 10 seconds? Okay, it's going to be like that. One moment. Sorry. How do you solve for the velocity at 10 seconds? Well, you'll note there it's not a straight line. So what do? We estimate, or guess. We make a line of best fit for that little curve spot. So what you do is you concentrate on that little spot, pretend it's straight. Now you take a ruler, and you make it continue the straight line through there. Now, here you have to play with it. Sorry, let me make my line a little thicker so you can see a little better. There we go. So what I'm trying to do is that spot inside the circle, try to make this blue line overlap it. So maybe that looks pretty good. Now, am I exactly right? I don't know. But I'm willing to guess I am. This is just another way of doing a line of best fit. Then we zoom out, and we extend this line. Now, of course, you guys are doing this with a ruler, so it's much easier for you. I'm on the gosh darn smartboard where I can't use a ruler easily. And I extend the line, and there we go. So now, I have a line best fit for that point at 10 seconds. Now, what are my coordinates? I don't know. I have to look closely at the line. Where does this line cross the grid? And hopefully, I'll get a couple of decent points. Somewhere up top. That's not bad. And down below, that looks pretty good. So there we go. So this is my rise. How are you, Poopy? Stop that. My run. So my rise, 1, 2, 3, 4, 5, 5.2, 5.4, 5.6, 5.8, minus 5.8 meters. And my run is 2, 4, 6, 8, 10, 12, 14, 16 seconds. So slope, rise over run, minus 5.8 meters, divided by 16 seconds. And I can't do that in my head. Negative 5.8 divided by 16 is minus 0.36 meters a second. Now, am I correct? No. Am I close enough and good enough? Yes. Now, what I'm going to do is the exact same thing for 50 seconds. I want you to pause the recording, and I want you to draw the line of best fit, and calculate the slope. We will come back and compare results. Okay? Okay, gentlemen. When I do it, I get something like that. Gentlemen and ladies, my apologies. Now, am I correct? I don't know, but am I close enough that I'm happy? Yes. So down here, that's a good grid point. And up top, that looks to be a good grid point. So there, remember, I want them far apart. Just and, well, no. The real point is the graph paper isn't perfect. So 2 grid lines far apart, or 2 data points far apart will be better than 2 close together. So slope equals rise over run. Now, to be specific, I really should be going y2 minus y1 over x2 minus x1. So this is 4.2, 4.4. So this is 4.4. That's my y value. My x value, 60 seconds even. That's 60 comma 4.4. And this point up here, 246 seconds. And 11 even. So this is going to be x1, y1, x2, y2. So this is going to be 4.4 minus 11 meters divided by 60 minus 6 seconds. I can't do that in my head. That's 6.6 meters over 54 seconds. And double check my math because I'm getting old. 4.4 minus 11. Yes, minus 6.4. Minus 6.6. And 60 minus 6 is 54. Divided by is negative 1.2. I'm going to make my minus sign just a smidge bigger. All right. Now, comparing to your answer, we should be close. Since this is a guesstimate, or an estimate, are we exactly the same? We shouldn't be. Should we be close? Yes. So I'd accept anything from like minus 0.1 to minus 1.5. I'd be happy. All right? Good. So that's it for me. If you got any questions, shoot me an email. Otherwise, good luck.